What is a hybrid energy storage system, HESS? In this session, we'll explore hybrid energy storage systems, or HESS. We'll see how combining different energy storage technologies can lead to better performance, reliability, and cost efficiency. Overview. A HESS is essentially the best of multiple worlds. It blends different energy storage devices, like batteries and ultracapacitors, so each can play to its strengths. This approach improves overall system efficiency, extends lifespan, and enhances reliability. Diverse storage technologies. The first principle of HESS is diversity. Different storage technologies have different strengths. For example, batteries store a lot of energy and are great for sustained use, while ultracapacitors deliver rapid bursts of power for short periods. Complementary characteristics. The second principle is complementarity. When one technology is less efficient for a particular demand, another takes over. For instance, ultracapacitors can handle high power surges, allowing batteries to focus on steady energy delivery. Power management and control. A key component of HESS is the Energy Management System, or EMS. This control unit acts like the brain, managing power flow between storage devices and ensuring the right source is used for the right job. Example application. A practical example can be seen in hybrid electric vehicles. Here, the battery supplies the main driving energy, while an ultracapacitor steps in during acceleration or to absorb energy during regenerative braking. Benefits of HESS. By combining multiple storage methods, HESS offers high power and high energy capacity, a longer lifespan due to shared workload, improved efficiency, greater reliability, and even potential cost savings. Key components and concepts. Key parts of a HESS include batteries for long-term storage, ultracapacitors for quick bursts, flywheels to smooth power fluctuations, and fuel cells for clean energy generation. Overseeing it all is the EMS, ensuring every part works in harmony.